All right, so now that we've created the default project, it is time for us to set up the worlds that we have. We do that by creating gameplay tags. In the OtherWorld system, the gameplay tags are what identifies your world states. A world state can be a dimension, a timeline, or a state of the world. For instance, you could set the whole world on fire, freeze it over, or you can jump backwards in time or forward in the future. You can also jump between different versions of your own reality, and that is where the strength of the OtherWorld lies. We do that by going into Edit in Project Settings, and in the project settings you can look for the gameplay tag. When you find that, there is this button here called Manage Gameplay Tags, and this is where we set up the gameplay tags. In my case, I'm just going to call it World A, add a source. I'm just going to do another one called World B. But this could be anything. You can have World AB, you can have Timeline ABC, or Timeline Past, Present, Future, or you can have World States, World on Fire, World on Ice, etc., etc. So now that we've set up the world states, the world tags, it is time for us to make sure that actors actually exist within a world. And we do that by adding a component to our actor. This is the default scene that you see when you start off the project. And if you don't have it, this is the scene that's loaded right now. In the third person folder, there's the LVL third person. And within it, there's also a blueprints folder. And this is where our actor actually exists, the player, the character. Which is perfect, because this is where we want to add the intersection between the other worlds and the actor that is supposed to be reacting to world state changes. It is important that you do this for the character, because the character will be used as a base for activating and deactivating the world states, the world entities. We do that by adding a world entity component. And this is basically all we need to do to make sure that an actor actually interacts with the system. On the right side here, you have these two properties, which are important. The first one is which world will the actor start in. In our case, I'm just going to set it to world A. And also which worlds will this actor actually exist in. And the player, you usually want it to be existing in all worlds, because you don't want the player character to disappear within a world. But you might want to change the state of it. One example with that would be changing from a physical state to a ghost state. If you'd play a character that would transform into a ghost in a way, you could make it invisible, etc. In this case, we just want to make sure that it exists in both worlds. We don't want it to disappear. And that is all we need to do to make sure that the character exists in all worlds, and it starts off with the world A. Now that we have the character set up, we want the character to move around, but also see things in different states, right? But we don't really have anything that reacts to world state changes. So let's go ahead and add a few boxes. I'm going to go ahead and create a blueprint class of type actor. I'm just going to call it world cube. And the world cube will have a static mesh, a cube, and of course the world entity component. The world entity component needs to be set up, but in this case, since we want the box to be instantiated multiple times, they will all have different settings. So I'm not going to touch this right now. I'm going to do it within the level. So just drag and drop a few instances of them here. This one will be starting up in world A. and it exists only in world A, and the other one will start off in world B and exists only in world B. And if you start running now, one of them is gone. Now that we have two cubes, one that exists in world A and one that exists in world B, and we have a character that should be able to traverse between world A and world B and see different versions of the world, we don't really have a way to do that. The easiest way to do that is by adding a portal. So let's go ahead and do that. We right click here, add the blueprint class of type actor. BP portal is what I'm going to call it. And this portal will have a static mesh. This static mesh will have a rotation handle full. And if you don't see this rotation handle full, you can do that by clicking on the cog here. Make sure that you have engine content checked. With this in place, we don't want the character to interact with the mesh here. So I'm just going to go ahead and do custom, ignore all the collisions, and that's it. This is still just a static mesh. And in order for us to be able to portal between different worlds, I'm just going to add a world portal component here. And the world portal component is basically a cube here, which maps out where the player, which it overlaps, will be able to traverse between different kinds of worlds. So I'm just going to go ahead here and change the size a bit. I'll do that with the box extent, say 10, and then 50, nope, 80. Let's go with 100 and 100. A bit of overlap. All right, and that is all we need to do. Now there are some settings here for the other world, where we have world A and world B. This is not to be confused with the world tags that we used. It's just a coincidence that we call it world A and world B. These tags are not tied to what this property is called. The reason why it's called world A and world B is where do you want the destination to be and where do you want the source to be. So I'm just going to go ahead, add this one. I'm going to rotate this a bit. And I'm going to say world A for the A part and world B for the B part. Now, if we play the game, we should see it over here. And when we move through it, we have now successfully traversed between two different versions. So now that we have two boxes that exist in their respective world, world A and world B, and we have a portal that enables us to traverse between the different kinds of worlds. Let us see what happens when we have physics enabled. For that, I'm just going to move this a bit upwards. And I'm going to go into the blueprint, select the cube, and make sure to select simulate physics in the physics section. Going back to the scene. When I play the game, this is what happens. Let me just move the character a bit so it becomes more apparent. As you would expect, this cube starts falling. I can interact with it, right? But where's the other cube? Well, it exists in the other world, and it didn't really transition, it didn't really happen. This physics didn't really start off because we weren't in that world. As far as this character is concerned, we're in one timeline where this isn't really existing yet. And therefore, the same thing happened with the character, with the box. And when I move back and forth between the portal, you can see the boxes have changed place, right? So if I take this box again and I push it over here, you would expect that to remain in the same the same place when you come back through the portal. So going into the world, I see this one here. I can move the box around, maybe push it onto a button, and I go into the other world again, and I have this state here for this little box. You can imagine this being part of a puzzle mechanic. This could be something in a platformer game where different kinds of objects, entities exist in different places, where you could just jump on them, switch world, and then jump again. So now that we have both boxes being activated and deactivated, and we've seen that the physics states are also being saved when we traverse between different worlds or timelines. And we also have the ability to traverse between different worlds or timelines. We don't only want stuff to just pop in and out of existence. Sometimes, for the gameplay purposes, we want to react to certain kinds of changes. For instance, when a box is being activated, we want to have a particle system being activated as well, or play a sound, or what have you. And we can do this in multiple ways. The most straightforward and easiest way to implement is we go into the blueprint, and on the world entity component, we see there are a few events that we can work with. There's the world tag changed. We have an entity activation event and an entity deactivation event. For now, this world traversal changed event, we'll just leave it be. So let's start implementing different events. We'll start off with the activation events, and here we get the actor that's actually being activated. In this case, it's the same thing, it's the same one, so it doesn't really, we don't really need to have anything here implemented. What we want to do is we can start off with just printing a text just to show you what happens. So we can take this, let's take the object, we take the display name. And we'll just print the name of the activated entity, the actor, sorry. So when we play the game now, we see there's nothing going on because this event didn't really fire off. Things already exist. But when we traverse into this, you see that the world cube 2 is being activated, and thus we get the print. If you move back into the portal, we see that the world cube, the first one, gets activated, and thus we see that this one also gets a print. The same thing can be done for deactivation. So let's just do the same. And I'm just going to remove this one so that we don't get confused with the activation deactivation. So now we only get output when we deactivate things. Since we start off in world A, the second one here gets deactivated. And now when we moved into the portal, the first one here got deactivated, and therefore we got the text. Again, moving back through the portal, we see the world cube 2 is getting deactivated again, and so on and so forth. The third one is the world tag changed. So this happens when an entity changes its world tag. What that means is whenever we move through a portal, the current world tag of that entity is being changed. And what it does is it just says which world it currently resides in. So when we move back and forth between different portals, we know which ones we want to activate and which ones we don't want to activate. Some components might have multiple states. For instance, the pausable entity component. This one has multiple states, and for the purposes of that component, the current world is important. But that's outside of this video for now. So let's do the same thing here. Let's just do a quick print here. And for that, I'm actually going to do a format string. And I'm going to format actor transition to from to, and I'm just going to get the names here, the tag name, and I'm putting the from into the from, the tag name from the to tag over here to the to in the format, and I'm just going to take the actor name and put it into the actor part of it. Again, I'm just going to remove this pin so that we don't get any confusion about the events. And as soon as I move through the portal, we should see there are two entities being changed here. Both of them changed their current world tag, being from the one that they were before into the second one, which the world exists in right now. Again, every time we move through this, we switch between the world they were in and the world they changed into. All right, but we don't really want to have the text, right? So let's go ahead and implement the sound thing. I'm going to remove this. And I want the sound to be activated when we activate the event. So let's just go for a play sound 2D for now. And I'm going to play a sine tone ping. So whenever I activate the event now, we should be able to hear a ding. And that's it. If you have an earlier version of OtherWorld, you might not see these activate and deactivated events, or rather just the on world tag event changed event, on world tag changed event. And if that's the case, then this is easily simulated by just implementing this one. And we can take the world entity and get the world tags. These are all the tags that the entity exists in. In other words, when I press this one, open up the entity here, worlds in which this actor exists in, this is what you would get from the get world tags. And in our case, we want to take that and we want to check if the world that we transition into is included in those tags that this entity exists in. And we can just use the hashtag function, the hashtag node, and we can just bump in the to world here to make sure that when we transition into something, this is the world that we want to check. The from world is the one that previously we're in, and that might be something that you want to be interested in. But for now, in this case, we just want to check, is the new world something that we are activated in or deactivated in? And let's just do the same thing here. I'm just gonna add the play sound node here. I'm gonna remove the previous one. So what we've done here so far is we check the world entity that we have. We ask it what worlds it exists in, and then we check the world that we just transitioned into. Does this include? Is this included in the places where this entity is existing in? And if so, then we play the sound. And there we go. So sometimes you also want to make sure that the portal disappears when you traverse through the portal to create these kinds of puzzle mechanics where you go through one portal to get into one world and then you have to find another portal back to the world that you came in from. And it's a really easy solution. You just have to open up the portal blueprint that we have, and we add the world entity to this one. And when we add that, we just need to make sure that when we select our portal, we go in here and choose which world it exists in, and make sure that we don't select multiple ones, or depending on the setup that you have. In this case, with only 2 worlds, we only want it to be existing in world A. So as soon as I traverse into this one, it disappears, right? So now I have no way to going back to the previous world. We can make a copy of this one. And I'm going to make sure that this one now exists in world B. So that when I traverse into the second world, the portal over here gets spawned, right? So that I can just move into it. And that is it. If you, like me, have chosen to use this ring as your portal setup, you can see that it actually never clips through the floor, right? And it's always rendered on top of everything. So when I run here, you see that it's rendered on top of me. And that could be really annoying if you want to see how far away you're from the portal. It's actually a really easy fix. All we have to do is open up our portal. We select the ring, static mesh, and just change the material. Since we're using the rotation handle from the engine, it uses a different material which gives this effect. In our case, let's just use the basic shape material. And that should be it. So now if you play the game, or even now, you can see that it's actually clipping through the floor. And when I play the game, I'm now correctly rendered on top of it before the actual portal. Sometimes we want to have full customization, right? We want to have objects that don't just pop in and out of the world. When we traverse into another world, say that we have a gameplay ability and we want to set the whole world on fire, we don't want the entities that react to world changes to just disappear. Instead, we want to have full customization, and we can do that by implementing an interface. But before implementing the interface, I'm just going to go ahead and create a material that will serve our purpose here as simulating enemies on fire or a phased object. In this case, let's just call it mphase. And the reason I'm calling this mphase is I will set the collision as not colliding with anything when it's phased out, and when it's opaque, when it's actually physical, that's when the collision will happen. So in this case, I just changed the color. I'm going to make this translucent one, make the opacity say 0.25. And I'm just going to show what it looks like in the game. So I'm just going to add the cube here, and I'm going to add, oops, this one to the cube. It looks transparent as it should right now. All right. So the first thing we need to do is we want to have a blueprints class. I'm going to make it an actor, call it BP phased cube. And this cube will have, this blueprint will have a cube, and this cube will have the M phase material by default. As I said before, we want to implement an interface, and we do that in blueprints by going to class settings. We take the interfaces part here, add an interface called world entity, and as soon as you press this on the left side, you get this interface part, and here we have all the functions that we need to implement. So let's just go ahead and implement all of them. And we also need a few variables. So I'm just going to call this one worlds. And this will serve as the worlds in which this entity exists in. We add a gameplay tag, gameplay tag container. And we can also do current world. This one will be a gameplay tag. We also want the previous world, which also is a gameplay tag. All right, so getting the world tags is basically just returning this world part here. Get the previous world tag, same thing, returning the previous world tag, and get the current world tag, we return the current world tag. The world tags, the current world tag, and the previous world tags are all used for activation and deactivation logic. Setting the world tag is the same thing as taking the current world tag and setting it like so. Well, we also want to make sure that we set the previous world tag to what we had before. And we do that before, like so. And then we can also do the same thing for, we want to do for the add world tag and the remove world tag. What these are, these functions are used when traversing between worlds. For that, I'm just going to go ahead and do this, get add gameplay tag, and I'm just going to, add, and the same thing here, but we remove. Again, these are used when we traverse between worlds and we want to add additional worlds where this entity exists in, or remove a place where this exists in. So now that we have the add world tag, we have the current world tag getters setters, and we have the world tag container getter and the previous world tag getter. We now only need to do the activation and the deactivation. And this is where the phasing comes in. All this has been for setting up the entity so that it also scales and works with the rest of the system. So what happens when we activate the entity? Well, we want to make sure that this gets a material, right? Set. You want to display to the player that, hey, this is now an opaque one. I'm just going to go ahead and use the basic shape material. And when we deactivate, I want to use the phase. Just to show things off that everything works as expected, I'm gonna skip the collision for now. Go in here, I'm gonna pull this one in. And I want to make sure that our cube here actually has the right entity tags, world's tags set up. For now, we don't really have any way to do that. So let's just go ahead and expose this world. And let's go ahead and do the current world as well. So with this selected, we now have the default section and the worlds where this exists in. Let's say it exists in only in world A, meaning that when we are in world B, this entity will be deactivated. As you saw there, we didn't really have this deactivated from the get-go, and that is because we're implementing everything ourselves, and we need to make sure that we, upon the beginning here, deactivate the entity. And we can use either the function that we have, or just use the interface. This is the interface version. Deactivate. Oops. And this is the function that we are on the instance, basically. I'm just going to go ahead and do this for now. Now, of course, here we could have more logic to see that, hey, what if the player actually starts off in the right world from the get-go? We shouldn't be activating it at that point. But for now, since this one exists in, let's make it exist in world B. It should be deactivated. Moving here, it will automatically make it activated. So let's just go ahead and make the small thing here with the collision. So collision enabled to no collision. When it is deactivated, and we want to make it collision both physics and query, like before. So now we're phasing through this. However, when we portal into it, we now have a physical object that we can't really do. And you can imagine this being a platformer game where in one instance you have this and you're just jumping through it. So you have to use your abilities to traverse into the second world where you can jump on it. Or you have these kinds of portals in places and you need to activate one so that you can jump over and complete a puzzle. This is actually a good place to start looking at gameplay abilities and how we can use the OtherWorld system to leverage the power of transitioning back and forth between worlds to create gameplay ability systems for changing the world state. For instance, setting the world on fire, or freezing hell over, or jumping in and out of the spirit world. So far we've talked about portals as physical things, like this portal here. You have to walk through it in order to be able to trigger a world transition. And we've talked about implementing an interface for the entities for custom behavior. To be able to transition manually, we can also implement an interface, but for the portal instead. But instead of having it as a physical object that you have to walk through, I'm just going to go ahead and implement it on the third person character. And by doing so, we enable button presses on the keyboard or the controller and directly interacting with the OtherWorld system to request a world transition. Again, we're going to implement an interface, and in this case it's called portal. And the portal interface here provides us with a few functions. The first two here are, just like the name implies, events that fire off when the transition has been completed and the transition has been initiated. For our intents and purposes right now, these don't really matter because we don't want to play a particle effect or make a sound or something. We just want to transition. The other three, however, are important. We'll start off with the can activate portal. This function is actually asked by the other system and requested to say, hey, can we actually traverse? Is this player actually being able to do this, or the entity, or what have you? Does this portal actually enable world transition? You can imagine this being on a cooldown, for instance, and you can't really traverse back and forth between the different worlds unless the cooldown has been ticking down to 0, or you need to have sufficient amount of mana to be able to transition into the other world. For instance, setting the world on fire requires 30% of your mana pool, whereas freezing it over might just need 25 or 15. For our intents and purposes right now, though, I'm just going to set this one to always return true, because this ability will just be a toggle. Speaking of toggles, we need to be able to determine what world we want to jump into. And that's what the determine target world does. So we need to be able to transition from one world to another, and depending on what world we are currently at, we want to know the next one. So for that, I'm just going to do an equal here and check if the world is world A. We're just going to traverse into world B. And if not, we're just going to go, and that means that we're in world B and we're going to traverse into world A. So once again, if the current world is world A, then we want to transition into world B. However, if it's not world A, meaning it's world B, we want to traverse back to world A. You can imagine this part here being some kind of an ability system checkup, so you already have the world on fire, so you can't really transition into world on fire again. Or if you toggle between various ones, this is where it's done, right? And then we can also have the actors to transition function. And the world actors, that the reason why we have this function is some portals only have a subset of entities that can traverse. For instance, in a foreshadowing scenario where you have a portal in a finite space, you just want to show off some mechanics, some actors, some entities. This is where that would be implemented. In our case, this is a perfect place for us to get an introduction to the various systems that OtherWorld ships with. And in this case, we want to know all OtherWorld's actors that exist, because this is a global thing, right? And for that, we have the world registry. There is one called OtherWorld registry, And it keeps track of the components and actors that you have in your scene that need to be activated and deactivated. And we can ask this registry, give me all the world components. And that's all we need to do for this one to make it global. And that's all we need to do to have this very simple mechanic in place. So now that we've implemented these functions, we need to trigger the actual transition. And for that, we have another system in OtherWorld called the Transition Manager. And this Transition Manager has a function called request portal transition. So that all we need to do is actually call this one. To be able to send things over here in the portal, which will be a reference to self, you need to have compiled it before, so that the Unreal actually knows that this is an interface implementing the portal, and it's actually going to be the same thing here. So the triggering actor and the portal itself will be the same, right? And we now just need to have a button to be able to trigger it. In my case, I'm just going to call debug num0, which would suit our purposes here. In your case, you probably want to do it more, use the input system using events, the input actions, sorry. But for now, this will serve our purposes. So compiling it, saving it, just go over everything again. We have something that would trigger the transition. We have the World Transition Manager, which handles actual transitions. We have a number of functions here. We have the can activate portal. In our case, I'm just going to go ahead and say that this is always activatable. We need to determine what world we want to transition into. In your case, this could be a skill tree, this could be a button press, etc. That will determine where you want to transition. We have the actors to transition into the new world. And in this case, I'm asking the world registry, hey, give me all the actors that we have in the world, so that we can transition them. These two functions, the complete and begin, are not necessary. Those are just used for visual effects or audio triggering or what have you. Anything that happens reacting to those kinds of interactions. So playing right now, we should be able to just press 0 to transition into the next world. Would you look at that? So I trigger it, everything's phased through. I trigger it again, now this is solid. I have the box here, and the portals work just as before. So let's go ahead and jump. Hey, I'm gonna just play around a little bit with this. And I'm gonna make this world A. And it's probably not gonna work. There we go. And the reason for this one being out of sync from the beginning was because we by default deactivate everything. So now we have a puzzle, right? So we have some kind of a stair-like puzzle. We jump here and we jump. If we don't change the ability, we just fall through. So I'm just going to use it and use it again. And ta-da! Now that we have a way to trigger the transition between the worlds manually, we can start off implementing some mechanics. One cool such mechanic would be to stop and start time, right? When you jump into another timeline, you just stop the time, and when you jump back into that to your default world, you just start the time again. Or as an ability, you literally just stop and start the time. We can go about doing it in multiple ways. One would be just to customize the interface, the face cube, for instance, that we had before. Make a similar one which implements the interface. But I'm going to go ahead and show you another way we can do this, and that is by subclassing the world entity. And I'm going to call this one actor component freeze time. Doing it the other way with the interface, we have to implement a lot of things ourselves, but with this, we already have a number of functions already implemented by the base class, and all we need to do is just implement the activate entity and the deactivate entity. And in this case, I will get the owner. Oops. Get owner. And from here, we want to set the custom time dilation. In the activation, we want this to be at 1. And in the second one, we want it to be 0. So when we deactivate the object, the actor that has this component, our new component, will be frozen in time. And when we activate it, it just goes back as if it were before. Now we could fire up events and things like that. And we can also right click here, add the call to parent. And when we do that, we get the default behavior, which enables, disable the component itself. But for now, this will suffice. All we need is the thing to be frozen in time. And I'm going to go ahead and create, another actor using a blueprint here. And I'm going to call this projectile, time projectile. And the time projectile will have a sphere. I'm going to make the sphere a bit smaller, 0.25 maybe. Actually, I'm going to squish it a bit, 0.15. There we go. And I'm going to add the freeze time component that we just created. Again, we are not going to implement the OtherWorld starting world and worlds this actor exists in. Instead, I'm just going to drag and drop it here. And make sure that we set these properties here. So when it exists in A, when you transition into world A, it gets activated. When we transition from A to another world, this projectile will be deactivated. And in our case, since we made sure that we deactivate and freeze the projectile, it will be frozen in time. All we need now is just to rotate this. Let's put it here. You know what? I'm going to go ahead and add a projectile movement here so that we can see what actually happens. And we can see the effect of it. I'm going to set this initial world to 300, and I'm going to make it so that it snaps to the horizontal line. It's just constrained. I am going to squish it a bit here as well. In the Y direction. There you go, so that it looks like a projectile. And that should be it. So we should now be able to see this one move forward, as you can see. And when we stop time, we get a frozen in time projectile. You could imagine this being part of a cube. Let's do another one. I am going to make a copy of this BP moving platform. And instead of having a projectile movement, I am going to have a rotating movement. And instead of a sphere, I am going to have a cube. And this cube will be a bit squished. Let's make it a bit bigger. So this one here will rotate. You know what? I am going to make it this way instead. And the rotation will be in the z-axis. Let's do it a bit quicker. Let's say 720 degrees for the rotation rate. And since we have a freeze time component here, this should also be stopped within time when we trigger the ability. And that means we also need to set this up. So when we're in world A, it starts, it is moving, and when it's in world B, it stops moving. Oh, that was a bit quick. But if I freeze the time now, you can see this platform is now frozen in time. Whee! So now that we have talked about the world entities, their components and their interfaces, we talked about the portals, both the components and the interfaces, and we've implemented some basic mechanics that we can do with this OtherWorld system. We still have no way to pull one thing from one world and make it traverse into another world. Let me demonstrate real quickly. Taking this object here and pulling it through the portal doesn't really do anything because there's no real interaction between the portal and the world entity, and only characters can actually trigger these transitions. As you can see, this object is still in the same place even though I pushed it through the portal. The same thing happens if I go for an ability-based transition. And for that, there's in an interface that is called a world traveler. And world entity components by default are actually already implemented in this interface. So the only thing that we need to do is make sure that this cube here, which already has that component, can be grabbed and pulled through the world. And I'm just going to implement a basic grabbing mechanic here. This is by no means best practice, but it gets the point across. So first off, what we need to do is I'm just going to show you first the interface. The world traveler, as soon as I have it select there, the OtherWorld tab here gets shown. The drop down collapsible. And there are two functions. We have the is traversing and the set is traversing. Now this should be set on the actor that will be traversing between the different worlds, meaning our cube and not really our character. So I'm just going to go ahead and remove it. And remove all traces of it. So in essence, the entity component of the world cube here is supposed to be handling the traversal. Now again, the world entity component does this by default. And all we need to do is grab this and pull it over. So let's go ahead and do that. I'm just going to add the ability to do so by, again, a button press and doing the debug key num1 this time. And what we want to do here is we want to grab something, right? But we need to know what we grab. And this implementation is probably not the best way to go about it. It's just one way to show you how to traverse one thing from one world, one entity from one world into another one. So to do that, I'm just going to go ahead and do a sphere trace. I'm going to do so by channel and just plug in some nodes here. For the starting position, I'm going to have the actor location. And I'm going to do the sphere trace end here at an offset from the prey location. So for that, I'm going to need the the character forward. Oops. Get actor forward vector. There we go. And I'm going to multiply it with some offset. 100. And then I'm just going to add this one back to our actor location. And there it is. I'm going to have some radius. And this is what our sphere trace will look like. So what we do right now is we take the actor location and we sphere trace it into a forward vector in a forward direction from the character that we're playing with. And if we have something, if we actually hit something, we want to grab it, right? And for that, I'm going to use the Unreal Engine physics handle. And the reason for that is the physics handle actually has something called a grab. You can actually grab something. And there's the function that we want to use. Grab the component at location. And it requires a component. So let us split this structure here and take the actual hit component and move it there. And we want to grab this at the location of the center of mass. If we grab it at the center of mass, it's not going to wobble around like a pendulum, for instance. It will probably rotate if you hit something, but you're just picking it up from the center of mass, basically. But all this doesn't really have to do anything with our entity, and we're not really setting anything on the entity. We're not telling it to be prepared to move between the worlds. So let's go ahead and do that. I'm just going to take the actor. I'm going to find the interface that actually implements this. Component by interface. There's a get component by interface node, and what we're looking for is the world traveler interface. And the world traveler interface is basically a way to notify the OtherWorld system that, hey, this thing that we have right now is about to enter another world. It's a world traveler. And our world entity component actually already implements this. And this is where the event that I was talking about really quickly in another video, I actually just mentioned it. The world traversal changed. This is when it's going to be fired. When we actually move from one world to another. When we set the world traveler to be prepared to move between the different worlds. Really quick here, I'm just going to go ahead and show you what the world traveler interface actually looks like. It is literally just a setter and a getter. And under the hood, it's just it could be anything like a boolean. I'm just going to remove this one, because our world entity actually already implements this. So our boxes that we have with the components that implement that use the component world entity, they are already usable. They can already be traversed between different worlds. Whereas the ones that we have with the interfaces need to have an additional interface implemented if you want to be able to move them between. And with this one, we want to have a version of it, and we want to make sure that we set the traversal set is traversing to true. And this is it. So we're grabbing something that we look for, which is the world traveler interface, that it actually has that component, and then we're setting it to traversing. And I'm going to go ahead and do the same thing, but in the reverse order, so that we can also drop it. Debug key numpad 2. And for that, we're going to take this one. We're going to set release the component. But when we want to make sure that we release it after we actually have set the traversing state to false. And this one has a property called grabbed component. So we can grab it, take this function, and take the grabbed component, we get the owner of it. Oops. We get owner. And we want to do the same thing here. We want to get the component that actually implements the interface. I would set that to false. We also want to make sure that this is done before we release it, because otherwise the grabbed component here will be null and this check will fail. All right, this is not completely done yet, but what we have done so far is that we can grab something and we can drop it. However, when we press something, we don't really see anything happening, right? If we move over to the other world, it is still with us. It's just that it doesn't follow our character around. If I drop it, it's now set to the new world. I can traverse back and you can see both of them are indeed in the same world. I can pick it up again, move to the other world, drop it, and you can see they now toggle on between the worlds. So let's do the last thing here and make sure that we actually have something following us around. Before that, I'm just going to go ahead and implement the take function. And I will take the physics handle, get the grabbed object, I'll set the target location. And the location that we want to be setting is what we've done before with the sphere trace, meaning our actor location with an offset. So this is just going to be in front of the character. But of course, you don't always have the grab component, right? So you need to check, do we actually have something here? Otherwise, you'll just get errors. Let's see if this is valid. And if so, set the target location where we want it to be. So now when I pick it up, we can see we can pick it up. It's actually colliding with the character, especially since we're wobbling things around here. It is still colliding with the world and also the character. Now I switch the world, I drop it, and you can see they both now exist in the same world. So let's just go ahead and do the last thing here and just remove the collision. And I will do this over here after we have grabbed the thing here. I'm taking the component, set collision response to channel, and I'm going to set it to ignore the pawn. And then do the same thing here when we release it, but the opposite direction. So I'm just going to take the component here, the grab component, and instead of ignoring the pawn, we should now block it. And as you can see, it works great. Of course, it's still occluding us, the camera view, and that's why you see this little zoom in there. But if I take this one now and I jump into the other world, you see it follows me around, I drop it, and I can jump between the worlds, and you can see it actually works as intended. And I can do this with the portals as well, because you can see they actually do as intended. And that is how you make sure that you, when you're running around and you pull things from one timeline, you can actually move them to another timeline. In case you're interested in the event, let's go ahead and do that. We can actually implement the OnWorld traversal changed event, meaning that at the time as when I am changing the state on these cubes, I could play a particle effect, right? But at this time, I'm just going to go ahead and play a sound. And I'm going to go, let's see if we can have some good one. Maybe the click on button, where we pick it up. And this one when we drop it. So let's do a branch here. If it is traversing, meaning we just picked it up, right? And we want the click on button, and if we want to drop it, meaning we can just take the shutter here, and you'll see as soon as I pick it up, it plays. There you go. This is how you handle it.